Hi, everybody. This is Monica Paolini from Senza Fili, and today we're talking about Terragraph and the opportunity that it opens in using the 60 gigahertz band where there is a lot of bandwidth, and it's unlicensed in many countries around the globe. And with me today, I have Mark Kelly, who is the strategic partner manager at Facebook. And we'll have the opportunity to talk much more about why Terragraph, why now. So Mark, thanks a lot for talking to us today.
Welcome.
And Mark, we've known each other for a long time. So, but you can tell us a little bit about what is that you're doing at Facebook, and what is that Facebook is doing in the infrastructure business.
So everyone knows what Facebook does. We have a family of social networking apps and a lot of happy customers. Our customers get their service primarily on mobile devices, but also on desktop devices, as you know. And so the performance that our customers see on their products, as well as getting new customers online, is pretty much dependent on the networks that they deliver the service to them. Over the course of time, the company has developed relationships with all large mobile network operators and others around the world. And through the course of our own business and interacting with them, we try to help them out as well as helping our customers out because they're interrelated. And so through that process, we've come to learn that there's areas where we could contribute from a technological standpoint, a system standpoint, and a business standpoint that can help our carrier partners in the ecosystem. And so you'll see a number of different initiatives that Facebook has jumped into, from fiber technology we're going to talk about today. And that's really the intent there. Our intent is never to be a service provider. That's someone else's business, or to be an OEM and sell these kinds of infrastructure products. The company does sell hardware products more recently, about Portal, and this is a good example, as well as Oculus. So there are products the company makes, but those are really more consumer driven and not in the infrastructure space.
Yeah, so how did you end up working on Terragraph on a personal basis? Because you've been working on wireless technologies now for quite some time. And what is it you're doing? How you ended up deciding to work on Terragraph, and what is that your role within the Terragraph at Facebook?
Sure. So I've been pretty interested in working on different millimeter wave projects predating Facebook myself, and even had a couple of them that were trying to kick off service provider businesses based on millimeter wave. And the observation I had during that time is not news to anyone probably watching this. The cost and performance of millimeter wave systems really took off. Cost going down, performance going up, to the extent where you could buy a 60 gig point-to-point radio, which delivering gigabit speeds, just buy it online for a few $100s. That's sort of so spectacularly different from a performance and price standpoint than if you go back in time to the early part of the last decade, where E-band radios were really the only game in town. When B-band radios came along, they were prohibitive and not really where they got to in price point. So this really opened up a new opportunity for service providers for high capacity transport. In my interaction with different companies and doing some different work in that space, I ended up hooking up with Facebook. Was doing some work with them and ended up coming on board full time. And thankfully, because I love what we're doing, working on Terragraph, working with our OEM partners and helping the product team drive the technology.
Yeah, and 60 gigahertz is nothing new, and even 802.11 is nothing new. So we have it for a long time. But what happened lately, that Terragraph has become a very hot topic. And maybe you can sort of give us a little bit of a perspective, historical perspective of why now? What changed? What are the major? What is the inflection point here?
So just from a technology standpoint, a number of things have happened over the last decade or so. I mean, if you go back, I think go back to, let's say, 2005, so 16 years ago, that was sort of the first time we were seeing custom IC CMOS for millimeter wave. And so really, as technology was advancing from phased array systems that were used primarily for military into phased array into commercial applications, from millimeter wave being somewhat exotic and machined horns and so forth with 70, 80 gigahertz down to basically phased arrays that are planarized. And so those pieces of technology combined to make Terragraph possible. Over and above that, as we all know, the capacity demands keep growing at it's not quite doubling every year, but it's going, I think, at a 50% CAGR. And so it's we're all dealing with this hockey stick phenomenon of broadband growth, but flat or declining revenue. So the idea is, what can we do to meet this increasing demand at a lower cost basis? And so a lot of things start with spectrum, as you know, in the wireless world. And when you look at the 60 gigahertz spectrum bands, it's really mind-blowing when you compare it to other bands, right? There's up to 14 gigahertz of unlicensed spectrum in this band. And just an insider story, when you were first developing this and making this big bet that Facebook made and started putting a lot of resources onto Terragraph some time ago, one of our first pitch decks really pitched it. It's described 60 gig as the band nobody wanted, because you're right, it has been around for a long time. And there were a lot of potential applications, consumer electronics applications based on 802.11ad, so WiGig, that really haven't hit huge volumes yet. So where else could this technology use? How about outside instead of just inside? And how about a scheduled transmission that's really conducive to high availability, high quality transport for a wide array network? That was the fit that the company saw. And that's really the origin story. As we were meeting with people around the world and seeing how expensive it was to lay fiber and how long it took, we're really kind of looking for a way to do that much faster and do it much cheaper and do it where you didn't have to go buy really expensive spectrum, where you didn't have to trench the street or even micro trenching. But you could have the reliability of that level of service and the capacity that provides. So between CMOS chip advances, phased arrays, I'd say high capacity network processors, multi-core, 10 gigabit per second packet processors, and frankly, larger channel bandwidths, right? You're looking at channel bandwidths today in 5G and at FR2, and they're 400 and 800 megahertz. These are two gigahertz channels that we're working with here. So you don't really have to drive a high order constellation to get high performance through them. There are other issues, but there's a lot of pluses in 60 gig. It's free, not everywhere. And that's another effort that we have been engaged in over the past several years as well. It's sort of working with regulators around the world, really introducing the technology and showcasing the benefits that it can provide. So that's really why now, I'd say. It's a number of things have come together, not the least of which, and probably the most of which, is market demand. And you're seeing, by the way, millimeter wave in other areas just meeting this demand as well. But it's a perfect time for Terragraph.
Absolutely, and it's a good opportunity to start using millimeter wave bands spectrum more. Now, you mentioned WiGig and you mentioned millimeter wave, that's used for 5G. So let's just try to sort of split here. I mean, Terragraph is not WiGig, although you're based on the same 802.11 standard. So what is that Terragraph is good at, and what is that is not? What problems is trying to solve, and what problems is not trying to solve?
Sure, that's a good question. So fundamentally, WiGig is an access technology, right? And so it's going from, let's say you had a 802.11ad hotspot. You could go right to a device of some kind of phone, VR glasses, something else, and get high bandwidth out of WiGig. 802.11ay or Terragraph-based standard is transport oriented, right? You're not going to put the access layer will come from some other means, right? It'll come from, in the case of fixed wireless access, either direct connection or a Wi-Fi connection. And in the case of mobile backhaul, of course, it'll come from a 4G or 5G radio. So the access layer is a different tech using a different band, and the transport layer is using the 60 gig band. And so that's for the big difference between the two. And that's a lot of confusion that we've seen in the marketplace early on, although most people seem to understand the difference. Really we're trying to replace a fiber optic cable with Terragraph, to be blunt. If you had fiber going in the same areas already trenched or aerially hung, you probably wouldn't need Terragraph, except for a couple of maybe right-of-way issues in terms of last 100-foot connections. But that's the big difference, I'd say, between those two.
Yeah, and it's important to keep in mind, because you don't want to try to do too much and then, we need to define it well. Now, another thing that when we think about 802.11, we think of, unlicensed is one thing, the other thing is interoperability. Are we going to have interoperability within Terragraph?
That's our intention, and that's what we have been working on, we'll continue to work on going forward. And so the idea that you could have a transport network, but today our OEM partners have a great set of SKUs that will meet both ends of the link. And I think they're doing a great job there. One of the things that we've realized in some groups that we've worked with, I wouldn't call them focus groups, but talking to people who want to deploy fixed wireless, these are service providers, ISPs, and so forth. What we've seen is a variety of questions about, couldn't you make a node that's built into the light on my house? Couldn't you make something that was, as small as a mouse, that sort of thing? Are there other areas that you could really innovate on the client side? To your point, the way you see in Wi-Fi. Again, it's not an access layer, but the idea that you could have an interoperable link is sort of key to what we're trying to do and globally scale it. So that's the intention, yes.
Yeah, and I guess we want to balance interoperability with the ability of different vendors to differentiate. And it's always a little bit of a tight line. I mean, you need to strike a good balance there.
You do, and the OEMs have their secret sauce, if you will, in different parts of the stack. And as long as the interoperability is maintained, then they're good to go. If they have, I think we've seen products in the market today, there are many of them, where they'll do Wi-Fi, but there's another physical layer, or there's some adjustments to it, let's say, or a different MAC that allows some other features that they have, which, as long as they maintain interoperability, their radio product still works with Wi-Fi. But if you have their receiver on the other end, there's enhanced feature sets. So we could see that happening, but that's sort of a way to have the OEMs be able to drive their own business, but also really help them by driving it with a different set of potential client nodes and the devices as well, and maintain interoperability as the standard evolves.
Yeah, and I think that what we've seen over the last few years is the growth of a very good ecosystem that goes from the chipset vendors all the way to the vendors, service providers, and so on and so forth. How do you see the role of Facebook in all of this, in driving and enabling this ecosystem?
Sure, that's a great question. And really the ecosystem is where our focus is. You mentioned interoperability, that's probably one of our top focuses, but I'd say number one is the ecosystem, right? So in order to drive, deploy, integrate into existing networks, have something that's healthy and has new features added over time, we have pursued a number of different areas. Global regulatory unblocking of 60 gig. It's not really that it's blocked for any particular reason. It's just, this is an outdoor use, different power levels. It's different frame structure. Usually not interested in that, but outdoor use at higher power in some areas is what we've worked with global regulators on. So that's part of the ecosystem, is the spectrum side. Another part of the ecosystem is just line of sight network planning with 5G millimeter wave and with Terragraph, where you have line of sight as the transmission method. That puts a little bit of a burden on a conventional planning tool, which will have, let's say, lower frequency propagation models. That we know how those work. Those are fairly well understood after all this time, but having a line of sight model really requires, in many cases, high resolution LiDAR data and a tool that can both accurately estimate the path length, any kind of impairment in the path, even Fresnel zone impact in the path, was something that we developed ourselves and are freely licensing to our OEM partners. And so that's another part of the ecosystem. I'd say the other areas that we're contributing to the ecosystem is really helping to train system integrators and involve system integrators, because the whole business of, if you plan the network, you understand the demand, the need, whatever the use case happens to be, then you need to be able to deploy it and operate it optimize it, diagnose issues that pop up in it. And to that end, our own internal engineering team, obviously over the last several years, have become fairly adept at doing that. And we're just trying to spread this knowledge around and share it. So that's another key part of the ecosystem: network planning, spectrum, system integrations, system integrators. They're all key to the ecosystem, and that's really what we've helped to do, and will continue to do for the time being.
Yeah, and so basically you're working more from the IP point of view, support and creating the right links, but you're not, as you said before, you're not interested in being a service provider. You're not going to produce equipment. It's more sort of enabling the ecosystem to develop and grow. Is that
correct? I mean, if you look at the origin story again, we made a big bet. Won't go into all the details of that, but we spent a fair amount of our own engineering resources figuring out how we could make it work, changing the MAC layer from CSMA to TDMA, TDD, making it transport friendly, working with the standards body. So we did all of this work in order to create something that could scale globally and be harmonized globally, as opposed to sort of a narrowly focused thing that might become proprietary and not have the same ability to spread the way Wi-Fi did globally over time. And so for now, we're heavily involved in it. I see that happening for the foreseeable future. But we believe this is going to scale globally in huge volumes. It's more than just our desire. It's the signals we're starting to see and a lot of the feedback we're getting. At some point, Terragraph will obviously take on a life of its own. And work we've already contributed to with the WFA and others getting involved in the ecosystem it'll sort of be out of our hands at that point. We'll still contribute, but it won't be to the level we are right now.
Do you think that we're going to see a larger number of contributors in terms of like chipset vendors and all that? How is that? Do you think it's going to develop moving forward?
If there's a great market, other chipset vendors will want to get in on it. Other OEMs will want to get in on it. We absolutely, other types of service providers will obviously want to contribute as well. Absolutely, we see that happening as well, whether it's a new chipset provider or, to your point, others who are developing other novel products that could fit into the space. Absolutely.
Now, I just remember that if we go back a little bit more on the technology side, one of the key features of Terragraph is that you're using a mesh, which is a great, it's one of those things that it's a great concept. Everybody loves it, but at the same time, there is a little bit of a reaction, like, what's happening to the latency, does it scale and all of that. Do you think that, first of all, do you think that the current status of Terragraph is mature enough to support this scalability? And how is that mesh going to help us specifically in 50 gigahertz?
Good question. Look, the mesh is a key element of Terragraph, right? So you could have a point-to-point, they're already point-to-point millimeter radios, point-to-multi-point radios, and they're great point solutions. But think of a typical market that we'll go into. I'll give you an example. One of the largest TG deployments is in Penang, in Georgetown, the city. They needed bandwidth everywhere in that city. They were constrained from doing certain kinds of fiber runs, and it was just sort of really impossible to get much more than 50 or 100 kilobits a second out on the street there from anybody. But in general, the hotels, fixed services and so forth, restaurants, and a lot of the tourist business that they have there, you need to spread it. So how would you do that? That's really a key to Terragraph, is spreading bandwidth from a couple pop locations to cover several square kilometers. If you think of how you would do that without a mesh, it would be cost prohibitive. Again, and our intent here was to drive the cost down. So the mesh is a critical key element to spreading Terragraph in a particular geographic area. And our intent there, we thought a lot about that. You've probably seen, there's other systems that have been released using a layer 2 mesh. This is layer 3. So essentially every Terragraph distribution node is a router. So it provides this sort of limitless scalability. Really only limited by the amount of bandwidth in your system, how many fiber pops you have that are connected into your mesh, how you plan the mesh itself. So it's not every use case and application will require it, but the fixed wireless use case and spreading it in geographic areas of cities relies on it. and it is a key component.
So basically, the more dense the network, the more benefits you get from mesh. But then you have somebody can say, well, yeah, but the more dense the network is, the more interference can become an issue. So how do you balance the two?
You have to keep in mind that the beam coming off of a Terragraph distribution node is a couple degrees wide, depending on the way it's been implemented by the OEMs. But essentially, it's a pencil beam. So you essentially have this pencil beam. It's very quickly redirecting a point to multi-point situation or honed in on the next distribution node. Actually intercepting that signal or getting in between the beam and impairing it is somewhat difficult to do, as opposed to something like Wi-Fi that's spreading or any other kind of a RAN that's spreading in the beam from the antenna, but generally in a wide area. So fundamentally, the fact that there's a spatial isolation from the phased array on the beam kind of eliminates 90% of your problem on day one. But having said that, there's side lobes coming off of that antenna, and there are reflections in cities of metal, glass, and so forth. And we've absolutely seen issues that pop up. Like, why is there something happening over here? Oh, there's a reflection there. We can null and somehow adapt, and we can adapt to that. We have other adaptation features such as Galé codes. So there's adaptability with interference, but interference has not really been in a dense network an issue that we've seen really cause a significant amount of concern. Early on, when people asked about it, we shared with them a number of tests that we had done over about a 1-year period on campus with different devices. When you had one technology using the band indoors and something else outdoors, how would that might interfere? If you had a 60 gig point-to-point radio, how might that interfere? So we're trying to force it to interfere, as well as the sort of natural multipath reflections that you see in a city. But to date, we have a couple of tools we developed to identify and circumvent that. It really hasn't been a showstopper in any way with Terragraph.
Yeah, and again, it's with the use of mesh, it's a novel way to use a band that, again, as we were talking before, it's not being used all extensively before. And now in the last few months, we've seen a lot of announcements about commercial availability. So before we were talking about the dream of Terragraph, now we talk about the reality of Terragraph. And so could you expand a little bit about what's next? So we're going to see commercial deployments, but in terms of features, what is the path? What is that? How can we improve? Can you get Terragraph in different bands? What else? What are the opportunity moving forward that you're working on right now?
So with the large number of field trials that we have done globally, working with mobile network operators and other service providers, we've had the opportunity over the last several years to collect such information, and in some early deployments continue to collect it and see what's really driving them. And a few things have sort of popped up. One is that the standard allows for channel bonding, and that's now becoming available. So rather than the 4.5 gigabits per second coming off of a single channel, it's kind of close to double. And the good put off of that in a TDD, TDMA, after going through the MAC layer, is around 3.5 gigabits a second now, instead of about the 1.7 that we've been seeing in trials. So right away, you're getting higher capacity with channel bonding. The second issue that we get asked a lot about, or were early on, it's 60 gig, there's the oxygen attenuation. This how long does it really go? Is this 100 meters, 200 meters, 300 meters? And I tell you, we run links ourselves that exceed 300 meters, but it's wireless and millimeter wave wireless. So we built into the link budget, rain effects, oxygen effects, and so forth. But longer range was one of the issues. And now you're seeing OEMs coming out with SKUs that'll do 1 kilometer or more in high rain conditions, even with the oxygen, with point-to-point solutions, sort of bridging Terragraph. And you'll see that coming from several OEMs. They're already becoming available on the market. So that's another set of features. Another thing that's come up, if you look at a directed mesh like this, and just to add a point here, with a directed scheduled mesh, this isn't like your Wi-Fi mesh you might be familiar with, where the bandwidth keeps getting divided in half every hop. It's maintained across the link. It's about a millisecond per hop of latency. And so depending on, I think we've run up to 15 hops or more in our test systems. Uh, that's sort of the capability of the system today. But it's all 50-50, right? You're transmitting and receiving. You think of something switching on and off every frame. And so with 50-50, the last link that's going from the distribution node to the client node is constrained by that 50-50 as well. And if you were just to stop right there and say, that's really all I want to do, you're like, well, most of it's downlink, right? And I think the way that's set up in 5G today, most of the deployments are 80-20, which is like DSL or whatever. More traffic going on the forward link asymmetrically. So adaption of the mesh in particular areas to go from 50-50 to something else, 80-20, so you can deliver the full capacity capabilities of the link in the direction where most of the traffic is going. It's another feature. And these are features that just have come up through a scale of conversations, testing, trials, analysis, really globally. And so I think what you're going to see over time, as people begin to deploy it, they begin to use it in different use cases, of which we've talked about this before. There's more than just fixed wireless access, Wi-Fi, or mobile backhaul, which we can talk about, but venues, train stations, number of areas where there's simply super high megabits per second per square kilometer required. Let's just say high traffic density from a spatial standpoint. Terragraph's perfect for that. It's cheap, it's easy to install, provides the area, but there might be features that roll out of that. And I suspect those will either be baked into one of the OEM's products, or even introduced into the standard if it's something that applies across the board. So those are the kinds of features we're looking at. As far as operating TG and other bands, that's really not on our roadmap today. There's no reason you couldn't do it. But as we said up front, our intention here, you could run it at a licensed band, obviously, as well. But our intention really was to utilize this vast, unprecedented amount of spectrum of 60 gig. And really focus on features that enhance the productivity and the service case in that band.
Mark, thank you so much for sharing all your thoughts with us. It's been great. We've been exploring different dimensions of a Terragraph. And for all of you, thanks for listening in. And this is, you can read this interview as well and read the full report on Terragraph, and it's available at www.senzafili.com. Mark, thanks for being with us today.
Welcome. Nice talking with you.